So from the left we got negative 1, from the right we got positive 1. Those don't match, so it doesn't exist. Is there a y value at the x value 0? Is there a y value? Oh, come on. There is. There's a closed dot right there. When the x value is 0, there's a closed dot on negative 1. So that is the exact y value that you get when you get to the 0 for the x. Alright. Save that. Letting your ink dry. Those are always key. Alright. Alright, I'll find it for you here in a second and send it back to you. But I gotta get the other one. I don't know why that one didn't open. This one isn't it. Oh, there it is. Okay, it did open. Cool. Okay, this is a good one. We need to all talk about this. Use the graph of the function shown below in order to determine all the values of a. A would be an x value, for which the limit equals 0. The limit equals 0. Did what? Hold on a second. Pause for station identification. This is the all pre-calc network. Of the function. So we want to find all of the x's where the limit is equal to 0. That's a y. The limit is 0. Okay. If there are no values, no x values in that in that group, then we say the answer is the empty set. So we are looking for where the limits match, and the limits are equal to 0. It looks like as you come closer and closer to negative 5 here, we are getting a y value of 0 from the left and from the right. So negative 5 is definitely one of the answers to this question. I got another one coming over here. It looks like we're coming from the left, we're coming to 0, and from the right, we're coming to 0. So 5 is another one. 7, yeah. From the left, we're getting 7 or 0, and from the right, we're getting 0. So 7. You actually have 3 of them. Negative 5, 5, negative 5, and 7. All right, let's go back to our notes. Those are not our notes. Okay. Our next definition is increasing, decreasing, and constant. Everything, all those definitions, well, especially increasing and decreasing. Constant, doesn't really matter, but everything is moving left to right. Left to right. As we move through these graphs and we're deciding whether we're going to call this interval increasing or decreasing, okay, hopefully we're taking notes now, not working on developed math, which you can do at a different time. You need to stay engaged in the conversation so you can ask questions while we go. If everything's moving from left to right, imagine you're on a roller coaster with these things. I'm going to be asking you, are you going up? Are you going down? Or is the graph flat? Right? That's basically what you're looking at. Increasing, decreasing, constant. But you got to understand that you're moving from left to right. If you lose sight of that fact, you might get the wrong answers. Okay? So, what do you think about this graph right here? Okay? That is increasing, right? Increasing from negative infinity to positive infinity. As you move through the graph from left to right, that roller coaster would just keep going up and up and up. Sure, it's kind of gradual in the beginning. It gets kind of cool right here in the middle, but then it goes back to gradual, But you're still increasing. Nothing ever stops increasing there. What about this one? Looks like an exponential decay function. Would you call that increasing? Decreasing? That is decreasing? right? Not December, not deceased, but decreasing. Yes, I abbreviated, folks. Okay? People might think those things, but they're not. Okay? And yes, from negative infinity to positive infinity. This interval that I'm writing down, what are those? Those are x values, thank you very much. X values. The word increasing or decreasing is describing what type of values? Is it describing the x values or the y values? Is the word decreasing describing the x values or the y values? It's about the y values, isn't it? The interval tells you where that's happening. On the x's, the word decreasing or increasing is telling you what's going on with the y's. Just like the idea of continuities are x values, limits are y values. What about this? What? Constant, yes. Now, I don't know if they mean not to put, arrows on this thing, or maybe they meant it. Maybe they meant for it to stop. And I'm assuming that these things should be going on forever and ever and ever. I don't know. But yes, that would be the same thing, negative infinity. Let's just assume this one stops. Okay, now this is a really bizarre one, folks. This isn't anything normal. What about the section from negative 5 to 2? What would you call that from negative 5 to 2? Decreasing? I would agree with you. How about from negative 2 to positive 2? What would you call that? Constant. How about from 2 to 5? Increasing. Now you'll notice I've left off some things, haven't I? It's because that there's a little bit of confusion here. For instance, in second period, I did this. The question came up, why did you make those brackets and those parentheses? My answer is, I'm not really sure. Because I don't know which one it belongs to. Does the 2 belong to this one, or does the 2 belong, or down here? That should be negative 2. Stop. Seriously, you should yell at me and say, well, I guess if you're not taking notes, that would make sense. Oh, okay. My nickname could be Hot Butter. Should the bracket be there or there? I'm not sure. Why? Because I don't understand when I'm looking at this, which one it goes with. Now, if Mr. Prisbaki says, hey, I'm going to put a parenthesis there and a bracket there, I would not argue with him. It's got to go one place. But I don't think there's any way I could really argue one way or the other. This is kind of an oddball situation. We're going to see another one here in a minute where it's going to be clearly one way, but this is kind of a bizarre, made-up situation, okay? So there would be some flexibility with those brackets and parentheses kind of thing because, it's not clear. For each function, tell what intervals on which it's increasing and or decreasing. All right? The first one we don't need a graphing calculator for. Everybody in the room should be able to tell me a basic idea of what that picture looks like because you studied it in Algebra 2. Heck, you probably studied it in Algebra 1. What's the shape? That's a parabola. Now, the x plus 2, which way has it been moved? Left, right, up, or down? You got about 30 seconds to talk to your neighbor and confirm whether the x plus 2 is moving it left, right, up, or down. Okay, talk to them, see what they think. Don't touch a machine to try to graph it and cheat on me. Talk to them and see what they think. Now, for those of you who were arguing that it's going up, that would only occur if the plus 2 were on the outside of the square. This is either a left or right movement. And remember, when we're talking left and right movements, it always kind of looks backwards of your common sense. So those of you saying right, you are not. We're going left here, so if you said left, congratulations. Okay. For those of you wondering why that's true, it's because in this process, that x has to make up for the fact that you're adding 2 to it. So it shifts all the values to the left in order to make up for that. But and eventually we'll get into more of that idea of shifting things around and talking more about that. So do we have any, what's going on? Do we have any increasing intervals? Do we have any increasing intervals? Any part of that graph increasing? All right. From -2, all right, to what? To infinity. Now here's the part that I need parentheses on both ends. Absolutely need parentheses. No questions. There's no choices you can make. I'll tell you why in a minute. Like the last contrived example. How about decreasing intervals? -infinity to -2. Absolutely must have parentheses on both ends. Now, and there's no question about this. You're on the roller coaster, right? You're coming down. Right at the bottom. Right at the very bottom. Are you increasing? Are you decreasing? Or neither? For a split second, you're constant. And I do mean split. Because moving quickly, as soon as you cross over, you're increasing. So, we must not include -2 there at the bottom because it's not true that it's increasing or decreasing at that spot. And you'll talk more about that in calculus. Okay, you probably don't know what the next one looks like, so you do need your graphing calculator. Okay. X squared over x squared minus 1. And if you're using the old style calculators, you might need parentheses around your denominator. Otherwise, you're going to get it wrong. If you're using the newer style calculators, I showed you how to make a vertical fraction like that. Does anybody need any refreshers on how to make a vertical fraction on the newer style calculators? You can't do that on the older ones, unfortunately. should get a shape that looks something like this. If you didn't, we need to make sure you typed it in correctly somewhere. Okay, so we should have a shape something like this. Take a look at the equation that I've, let's see if I don't know if I can, yes, look at that. Look at those two equations right there. Is there any difference in the graph? Absolutely not. I just factored the denominator, right? Now, what are the two problems in the domain of this function? What are the two problems in the domain? Two values that you cannot have. Okay, you got 20 seconds. Figure it out. Come on, let's go. Two problems in the domain. Look at the function. The picture screams it at you. Come on, figure it out. Two problems in the domain. Two x values that are impossible. Alright, Miss Hensley, what you got? -1 and +1, thank you very much. What happens in the denominator if you plug in a -1 or a +1? You get a 0, that's a problem. Alright, we cannot divide by 0. Okay, so, those are no different. Okay, now. Let's look at this picture. Any increasing? Alright, give me an increasing interval. Like what's going on over here? Is this increasing? Is that section that I just drew with the red increasing? Yes or no? Yes. Yes. And what is that section? -infinity to what? -1. Bracket or parenthesis? You can't touch the asymptote. MC Hammer told us we can't touch the asymptote. Right? Yeah. Remember that domain problem? That -1, that's that boundary that we can't have. So right there, at -1, we got that asymptote running through there that I so poorly drew there. Okay? What about when we cross over the asymptote and we're moving from left to right? Sorry. Moving from left to right. What's going on in that next section? Is it still increasing? Yes, what's that increasing? Okay, now, as soon as you say -infinity, I know what's going on in your brain. Okay? This happens so often that I gotta get you. What are these intervals? Are these intervals that I keep writing x values or y values? These are x values. What are the words increasing and decreasing describing? Y values. Now, as soon as somebody throws out -infinity, now, I do not But I know what's going on in their mind. Suddenly they have switched to y values because they're thinking about this whole coming up thing. Remember, we want this snapshot right here. So, tell me again, what is that section? From here to here. -1 to 0, right? Okay. That happens all the time. Right? Where people in their minds switch X's and Y's, and I know what they're thinking, but got to break you of it. So what happens at the very top of that little hill? Very top, right at the top. That's constant, right? So that doesn't fit in increasing or decreasing, right? So I cannot put a bracket on this 0. And when I switch to decreasing over here, I'm not going to put a bracket on that 0 either. 0 to what? Please do not say negative infinity. Oh, thank you. 0 to 1. Right? That section right there from 0 to 1. Yes, I know the y values are dropping off the face of the planet. But we're talking about x values for these intervals. Alright? What about this part over here? Is that also decreasing? Yes. Is it multiple choice? See? Okay, so that was from what to what? 1. 1 to what? What's way out there on the graph? I mean, way out there to the right. Positive infinity. Do you think this graph has a horizontal asymptote? Just curious if you think it has a horizontal asymptote. Do you think this is, as you go out forever and ever and ever and ever and ever to the right, or forever and ever and ever to the left, do you think that it has a boundary that it never crosses? A horizontal one. Folks, that's like this. Just making sure. That's all. Alright, so do you think there's a horizontal boundary? If so, tell me what you think it is. 1? So, let me get this straight. You think there's a line here at y equals 1 that this thing's getting closer and closer and closer and closer to, but never will touch. I do agree with you, by the way. What's x squared divided by x squared? That's kind of going to clue you into when we start talking about horizontal asymptotes, and maybe a shortcut as to how you can find them with these rational functions. But, you know, that's for the future. Talk about that in days to come. Just was curious. I hope I didn't miss all those good definitions. I'll have to go back and add that in. Okay, the next one would require us to graph it on a calculator. Maybe I can quickly do this on Desmos for us. Let's get rid of that one. I believe it was x over 1 plus x squared. Stay with me. Don't go to the light. Not yet. Hey folks, what do you think about that weird shape that you've probably never seen before? Do you think it's bounded above, bounded below, not bounded at all, or completely bounded? That is completely bounded, alright? Okay? That doggone thing ate a lot of cheese, let's just say that. Alright, you think about that joke for a while. Okay, so this one was bounded. Yep. missed those definitions earlier. We talked about how this one was not bounded above because it keeps going up and up and up. It is bounded below. Yes, hold on. And so, just to finish this, so this other graph would be not bounded above, or not bounded below, right? But does have a boundary over the top. It could be a horizontal asymptote. It's not in this case. These have actual high values on the y side. If there's no boundary top or bottom, we say it's not bounded at all. This one is completely bounded above and below, so they just use this single term bounded. Okay? This one ate a lot of cheese. Okay? If you eat a lot of cheese, you will be the same as this kind of graph right here. And you won't feel all that great. Okay? Bounded above and bounded below. So the overall term